You know, folks, we talk a lot about hard work and grit, and trust me, those are crucial ingredients in any successful endeavor. Without hard work, nothing gets built, and without grit, challenges can't be overcome. But there's another element that's just as vital, especially in the world of engineering: precision. Precision is the backbone of every structure we see around us. Imagine a skyscraper towering hundreds of feet above the ground, reaching for the sky with its majestic height, or a bridge spanning a mighty river connecting two distant shores and facilitating the flow of life and commerce. These feats of engineering aren't just about brute strength and heavy machinery. They are marvels of human ingenuity and meticulous planning. They're about meticulous planning, careful calculations, and pinpoint accuracy. Every detail, no matter how small, is accounted for. That's where precision comes in. It's the invisible force that holds our built environment together. It ensures that everything fits perfectly and functions as intended. Without it, things literally fall apart. Think about it. A single miscalculation can lead to catastrophic failures. Every road you drive on, every smooth stretch of asphalt, every tunnel you pass through, carved through mountains or beneath rivers, every building you enter, they all rely on precise measurements and calculations. These structures are the result of countless hours of planning and precision. One tiny error, even a fraction of an inch, can have massive consequences. It can mean the difference between stability and disaster. That's why civil engineers are like the unsung heroes of our modern world. They ensure that our infrastructure is safe and reliable. They work tirelessly behind the scenes, ensuring that every structure is safe, stable, and built to last. Their dedication and expertise are what keep our world standing. Now, you might be thinking, Mike, that's a lot of pressure, and you'd be right. The responsibility is immense. How do these engineers achieve such incredible precision? What tools do they use to ensure everything is perfect? Well, they have a secret weapon, a trusty sidekick that helps them get the job done right, the Theodolite. This instrument is essential for achieving the level of precision required in modern construction. So, what exactly is this Theodolite I keep raving about? Well, let me break it down for you. In simplest terms, it's a precision instrument used to measure angles, both horizontally and vertically. It's a staple in the toolkit of surveyors and engineers. Imagine a telescope mounted on a tripod, with some fancy dials and scales thrown in. It's like a high-tech version of a pirate's spyglass. That's your basic Theodolite. But don't let its seemingly simple appearance fool you. This tool is a powerhouse of precision, capable of delivering incredibly accurate measurements. It consists of several key parts, each playing a critical role in ensuring accurate measurements. You've got your telescope for sighting distant objects, allowing you to see far-off points with clarity. Your horizontal and vertical circles for measuring angles, which are crucial for mapping and construction. Your leveling screws for, well, leveling, ensuring that your instrument is perfectly balanced. And your tripod for stability, providing a solid foundation for all your measurements. Now, you might be thinking, Mike, that still sounds pretty complicated. And you're right, it does take some skill and practice to master this instrument, but don't worry, it's not as daunting as it seems. Trust me, once you get the hang of it, the Theodolite becomes an extension of your own eyes, allowing you to measure angles and distances with remarkable accuracy. It's a tool that, with practice, can transform your surveying and construction projects, making them more precise and reliable. All right, so we've talked about the importance of precision and the role of the Theodolite. Now, let's get down to the nitty-gritty. How is this instrument actually used in the real world? Well, folks, the applications are endless. Take road construction, for example. Theodolites are crucial for determining the precise alignment and elevation of roads, ensuring smooth and safe travel. They help engineers lay out curves, calculate gradients, and even determine the amount of earthwork required. Then there's bridge construction, where theodolites are indispensable for establishing accurate pier placements and ensuring the bridge deck is perfectly level. These instruments help engineers overcome challenging terrains and water crossings, connecting communities and facilitating transportation. And let's not forget about topographic surveys, where theodolites are used to create detailed maps of the Earth's surface. These maps are essential for a wide range of applications, from urban planning and resource management to environmental monitoring and disaster response. Now, I know what you're thinking. Mike, enough with the theory, let's get our hands dirty. It's time to dive into the practical side of things. So for all you aspiring engineers and curious minds out there, here's a simplified guide on how to use a theodolite. Step 1, setting up. This is the foundation of accurate measurements. First things first, you gotta find a stable spot for your tripod. Make sure the ground is firm and level to avoid any shifts. Once that's secure, mount the theodolite and use the leveling screws to make sure it's perfectly horizontal. This step is crucial for accuracy. You don't want any wonky measurements, do you? Step 2, sighting. This is where precision really comes into play. Now aim the telescope at your target. This could be a surveying rod, a prism, or any other clearly visible point. Ensure your line of sight is unobstructed. Use the fine adjustment knobs to center the target in your crosshairs. Step 3, measuring. This is where the data collection begins. Once you've got your target locked in, take your readings. Be meticulous and double-check your values. The horizontal and vertical circles will give you the angles, which are essential for mapping out your sight accurately, while a measuring tape or electronic distance meter can be used for distances. Step 4, recording. This step ensures all your hard work is documented. Last but not least, jot down those measurements. Accuracy in recording is just as important as accuracy in measuring. A field book or digital data collector will keep everything organized and easily accessible for future reference and help you avoid costly mistakes. Proper documentation can save you a lot of headaches down the line. Remember, folks, practice makes perfect. The more you practice, the more proficient you'll become. So get out there, get your hands dirty, and start measuring. The world of surveying awaits you.